explain one topic for each stage. Stage 1 Fluids, Stage 2 Thermodynamics and Heat, Stage 3 Electricity and Magnetism, and Stage 4 Sound, Waves and Optics. The topics of these stages are related to our daily life, and it is why physics is so important to us.
Hi, my name is Roberto Carlos, and I'm going to explain you some topics about stage 1 related with the pressure concept. So first, we need to analyze a few questions, like for example, when we travel by plane and it changes its head, we feel like this strange sensation in our ears, but also when we get into pool and swim with certain depth, or how a void with less force can introduce a nail into a wall of concrete. Well, for those examples, we can conclude it is needed a definition of the reflecting relation of the force by the unit of area, the pressure. The pressure is a scalar quantity, and the units of pressure are newtons over meter square. Also, we have the algebraic equation that is pressure it's equal force over the air. About pressure and liquids, as I already mentioned, when we get into pool and we swim with certain depth, this water that surrounds us exert like some pressure in all directions, but this pressure is the same in all directions in a point. So the pressure is equal in all the parts of our body and in all the points. This can be calculated with the formula of Picage, that it's equal to density times gravity times height or depth. So with all the previous, it can be established that the pressure inside a liquid is directly proportional to its depth and the density. Finally, the atmospheric pressure. The atmosphere exerts some pressure in us, so it is called atmospheric pressure. The normal value of the atmospheric pressure is equal to 1.013 times 10 to the 5 pascals, but it can vary as the location and the region of certain point, like for example in Mexico City it is less. Now I'm going to explain it with an example of it. Now to have better explanation, I'm going to make the following exercise. So calculate the absolute pressure exerted by petroleum on the burn of a tank at 10 meters depth if the atmospheric pressure is equal to 1.013 times 10 to the 5 pascals and density of petroleum is equal to 800 kilograms over meter square. So here we have the data, and the formula of total pressure is equal to the atmospheric pressure plus the Picage. So now I'm going to realize the calculations. So first of all, we have to calculate the Picage because we already have the atmospheric pressure. So it's equal to the density times the gravity times the height. It's equal to 10. It's equal to, here we have the Picage. Now the total pressure is equal to the atmospheric pressure plus Picage. So this times 1.013.
Hi, my name is Raul Zuniga, and I'm going to explain you sound and waves. Sound is the product of a lot of vibrations that succeed due to a certain phenomenon. For example, two hands that are clapping. In this case, the sound is produced by the impact, which generates waves that later will give the ear something to be processed, the human ear. When these things are processed, they are sent to our brain, where they are transformed in our perception of sound. As you can see here, the sound is produced by the clap. The waves of the produced by the impact go to the ear, and the ear sends them to the brain, where they are processed. The form of the sound, or the way we perceive the sound, is changes according to the frequency. Frequency is the distance there is between the waves of a certain sound. Yes, like for example, when you give a very a sound that has the waves very close between them, this is going to sound different than like waves that are very far between them. And the formula for frequency is waves over second. This equals frequency, and frequency is measured in hertz. That is the inverse version of second. The Doppler effect, that is the main topic of this explanation, is, for example, when you have a Moore cycle that is moving away from a certain observer. In this case, we're going to have our observer here, as you can see, and the Moore cycle is going to move this way, away from him. This Moore cycle has a speed of 550 meters per second, and a frequency, and it produces a sound with a frequency of 800 hertz. And well, as you can see here in this explanation, the thing up is like the frequency that is going to be produced when the Moore cycle is moving. As you can see, there is a different quantity of space between the waves due to the movement of the same Moore cycle, and we're going to calculate the frequency that is perceived by the spectator that is static from this Moore cycle that is moving. For this, we're going to use a formula that is the frequency perceived equals the speed of sound over the speed of sound plus the velocity of speed of the Moore cycle multiplied by the frequency of the sound produced by the same Moore cycle. We're going to use plus because the distance between them is increasing, and the Moore cycle is moving away from the observer, and so the space is going to be bigger. It is worth to say that the speed of sound in air is 340 meters per second. With this, we can get with our formula equal 340 over 340 plus 150 times 800 800, and it's going to be a frequency per seat of 555.10 Hertz. Thanks for your attention.
Now I'm going to explain the thermal equilibrium. Temperature is the variable that determines the state of thermal equilibrium between the systems. In other words, when two systems have reached the same temperature, they are in thermal equilibrium. There is also specific heat, and it is the amount of energy required, and it is the amount of heat required to change 1 kilogram of a substance by 1 Celsius. It is called heat, and represented by the letter Q, to the energy that is transferred from one system to another under the difference of temperature between them. Thermodynamics is the study of heat and its transference in mechanical energy. Now I'm going to explain a problem of thermal equilibrium. So we have a glass of water and some ice cubes, and we know that the mass of water is 0.350 kilograms and its initial temperature is 15 Celsius. We also know that the mass of the ice is 0.150 kilograms and the initial temperature is minus 10 Celsius. So we are going to use the formula of Q equal mass times specific heat times change in temperature. So we know that we have one heat that absorbs the energy and one heat that releases it, and so we need to equal it to 0. So when we have equal it to 0, we need to change one to the other side, knowing that it is going to change to negative. So we have that mass of water times specific heat of water times delta temperature of water is equals minus mass of ice times the specific heat of ice and the change in temperature of ice. So we have that the mass of water is 0.350 kilograms, and we know that the specific heat of water is 4,186 joules over kilograms times Celsius, and we also know the initial temperature of water that is 15 Celsius. So we need to put the change of temperature, the initial temperature of water that is 15 Celsius. So we need to put the change of temperature that is final temperature minus initial temperature. And so we need to equal it to the other heat that is minus 0.150 kilograms times the specific heat of ice that is 2,100 joules over kilograms times Celsius, and times the change in temperature that is final temperature minus initial temperature. So we get that the final temperature of water is 1,465.1 final temperature minus 21,976.5 equals minus 315 final temperature plus 3,150. So we need to isolate the TF, and we have 1,780.1 final temperature equal 18,826.5. So we need to divide this number with this number, and we get that the thermal equilibrium is 10.57 Celsius.
Hi, I'm Joaquin Milo Villarreal-Hernandez, and I'm going to explain to you about the electricity, stage 3, electricity and magnetism. The first topic is electric energy generation. In the 19th century, the electricity has been studied intensively because of its proven advantage in other types of energy. For example, it can be transformed easily into other forms of energy like heat, light, and sound. It also can be transported easily in long distances by non-polarizing cables. In developed countries, electric charge is produced by different means like nuclear, thermal, and hydroelectric power. In nature, the electricity is evident when lightning strikes. To understand electricity, first we will analyze electrostatics, which studies the electric charge at rest. Electric interactions with matter are due to electric charge as a mass that is a fundamental quantity which cannot be described in function of basic and simple terms. But the electric charge is known by what thus is what it is. The second topic is the sources of electricity. The most known source of electricity is the battery. The electric battery was invented by Alessandro Volta, an Italian scientist. Volta discovered that when two different elements are placed in a chemical environment, exerted on them, and an electric potential was established. A battery can be built placing a carbon rod that can be found in an old battery and a zinc plate in a glass container with acid and water electrode. Another source of electricity is the dry cell, which consists in a zinc container acting as a negative electrode, and it centers a carbon rod is from which the positive electrode is. Also, another source of voltage are the mercury battery and the rechargeable batteries made of nickel and cadmium. The most important sources that transform mechanical energy into electric energy are generators and dynamos. For the last topic, I'm going to talk about household electric fields. The standard US household wiring design has 1020 volt hot wire and a neutral which is at ground potential. Then 120 volt wires are obtained by grounding them, and for the transformer supplying the household to that when hot wire is swinging positive with respect to ground, the other swinging is negative. The design allows the use of either hot wire to supply the standard 120 volt household circuit. For higher power application like cloth wires, electric range, or air conditioners, etc., both hot wires can be used to generate a 2040 volt circuit. For a better understanding to the electric circuits, I'm going to present you a little problem. Like we're going to, for example, if we have a battery of 18 volts and an electric circuit with three resistances, and we have the first one that is 5 ohms, the second one that is 12 ohms, and the third one of 15 ohms. To calculate the intensity of the current, we're going to divide the voltage of the resistances. So first we need to add all the resistances, like here, like 5 ohms plus 12 ohms plus 15 ohms, they're going to have at 13 ohms. So finally doing the operation, we're going to have 18 volts over 32 ohms that is going to be electricity current of 0.56 amperes.